You know, there's a technology that's on your phone right now. It's inside our biggest power plants, and it's even protecting priceless history. It's a technology that's so common, it's basically invisible. And yet, it is one of the most powerful tools we have for shaping our world. We are talking about engineered surfaces, and it's time to see what's been hiding in plain sight this whole time.
Okay, this sounds like the setup for a really weird joke, right? A massive industrial plant, a piece of history that's hundreds of years old, and a simple pan in your kitchen. I mean, what on earth could possibly connect them? Well, the answer is hiding right there on the surface of each one.
And there you have it. The answer is surface coatings. Now, these are not just simple layers of paint, not at all. We're talking about incredibly thin, high-tech films that are designed with one specific job to do. They're kind of like the secret sauce that makes our stuff work better, last longer, and do things they just couldn't do on their own.
So here's our game plan for today. First, we're going to look at the basics of this tiniest armor. Then we'll see how it helps us fight back against nature's constant attacks, and how it supercharges our technology. We'll also dive into how smarter surfaces are changing our lives, and finally, we'll get a little peek into what the future might actually feel like.
All right, let's start with this idea of tiny armor. Just imagine for a second that you could give any material a custom-designed shield, a shield that's perfectly suited for whatever challenges it's about to face. That right there is the magic of engineered surfaces.
See, the key thing to understand is that a material's biggest weaknesses are usually right on its surface. I mean, that's where it meets the world. It's where it gets wet, where it starts to corrode, where things wear down. So coating technology is really all about solving problems proactively, stopping those failures right where they begin.
Which brings us to our first huge battleground, the constant, slow attack from nature itself. You know, things like moisture, mold, rust, even sunlight, they are absolutely relentless. But with the right coating, we can actually fight back.
Take bamboo, for example. It's an incredible building material, it's super strong, grows fast, it's sustainable, but it has an Achilles heel. It loves to soak up water, which makes it the perfect home for mold. So, how do you solve a problem that's happening right on the surface?
So how'd scientists crack this one? Well, it's this really cool three-step process. First, they create this special nanocomposite. You can just think of it as a microscopic shield made of silver and graphene. Second, they infuse that shield into the bamboo using this high-tech soaking and baking process. And the result? You get a functionalized surface, which is really just a fancy way of saying the bamboo now has new superpowers.
And this just shows you the result perfectly. On the left, you've got normal bamboo, which is hydrophilic. It soaks up water. But on the right, the coated bamboo is hydrophobic. Water just beads up and rolls right off. The difference is absolutely night and day. The material goes from being a magnet for mold to being incredibly resistant to it.
And this isn't just for bamboo. This same idea of targeted protection is used everywhere. We use solutions with cinnamon oil to stop mold on wood. We use nanoscale titanium dioxide coatings to shield priceless historical documents from fading, and we use these super specialized coatings to stop the intense corrosion happening inside geothermal plants and pipelines.
Okay, let's move on, because coatings aren't just about playing defense. They're also about going on offense, about pushing our technology to perform at levels that were, not too long ago, basically impossible.
I mean, think about steel manufacturing. We make millions of tons of this stuff, and it's literally the backbone of our modern world. But making sure every single slab is top quality, that's a huge challenge. So where does a tiny surface coating fit into this gigantic industrial process? Well, the secret is a coating, just not the kind you might expect. It's actually a layer of molten, protective slag that floats right on top of the liquid steel. This slag layer is absolutely critical. It insulates the steel, it keeps impurities out, and it makes sure everything cools down nice and evenly. It's a functional coating, just a really, really hot one.
So how in the world do you control a liquid coating on top of another liquid that's thousands of degrees hot? You can't exactly just stir it. Well, you turn to math. Scientists build these complex 2D computer models to simulate exactly how the slag is going to flow and transfer heat. This lets them perfect the process and get consistent results every single time without all the costly trial and error.
And it all boils down to this one simple idea. In one of the world's biggest and hottest industrial processes, the key to quality control is managing a thin surface layer. By controlling that coating, you control everything.
And this obsession with surface performance, it shows up everywhere. You see it in the flawless, mirror-like finish of a new car, where coatings are engineered to level out perfectly. And you see it inside our electronics.
On high-density circuit boards, special coatings are used to insulate all those tiny pathways and stop signals from bleeding into each other, a problem they call crosstalk. Okay, now we're going to get a bit more personal, because this technology isn't just for protecting buildings or perfecting steel. It's being used to heal the human body in ways that are truly revolutionary.
You know, when you put a foreign object into the body, like a hip implant, the immune system's first reaction is to attack it. But what if we could coat that implant with a surface that actually speaks the body's language? Researchers are doing exactly that, by fine-tuning a coating's texture, its chemistry, its stiffness, and even how well it repels water, all to send the right signals to our cells.
The goal here is just incredible. It's not about just hiding the implant from the immune system. No, it's about actively controlling how immune cells respond. By designing the perfect surface, we can actually convince the body to accept the implant and even trigger it to heal and regenerate tissue around it. It's amazing.
And you know, there's a really beautiful symmetry here. This same fundamental idea, programming a surface to do a specific job, is what allows us to design these futuristic medical implants and what allows us to create the coatings that protect centuries-old documents from falling apart. We're literally engineering surfaces to manage our future and preserve our past.
Which leads us to our final question, where we get to look over the horizon. I mean, if we can already do all of this, what's next? What would it be like to live in a world where the surfaces all around us are no longer passive, but actively working for us? Just imagine a world with a lot less cleaning. Researchers are pushing towards coatings with these amazing new properties. Think about surfaces that are self-cleaning, anti-fogging, and stain-resistant all at the same time. Windows that clean themselves every time it rains. This isn't science fiction. This is what people are working on right now.
Or let's think even bigger. What about a single, soft hydrogel coating you could apply in your home that does 3 jobs at once? It makes the surface flame retardant, it kills harmful bacteria on contact, and it prevents grime from building up. One single coating, giving you multiple layers of intelligent protection in your daily life.
And that's really where we'll leave it. From fighting mold on bamboo to healing our bodies from the inside out, engineered surfaces are a hidden technological revolution. This technology gives us the power to change the fundamental properties of almost any material out there. So the only real question left is, what problem should we solve next?